Hey guys, so welcome to this video. Today we're going to be looking at small angle approximation. So these are the identities that we're going to be using. This little squiggle equal sign just means approximation, by the way, if anyone didn't know that. So what happens is when theta is really small, and we have sine theta, this is approximately just theta. With cos it's a bit different, and I'll tell you why later, but it's just 1 minus theta squared over 2. And tan theta is exactly the same as sine theta, it's just equal to theta, or approximately equal to theta. So we're going to look at a simple question to begin with to show you how it's being used. So here we have theta sine theta. Now if we use our formula where sine theta is approximately equal to just theta, we'll get theta squared on the top. On the bottom it gets a little bit complicated, but we get 1 minus, and then cos theta, because theta is 1 minus theta squared over 2, so you put that in, and then this is what we get at the bottom. Take away our 1's, so we get theta squared over theta squared divided by 2. The 2 comes at the top because that's how division works, and then the theta squareds cancel to equal 2. And that's just a simple question on small angle approximation. So this is more of a wordy question, and like questions you should look out for in the exam paper. They're obviously small angle approximation being an easy subject, they're going to give you some confusing ideas to think about, and this is one of them. Given that theta is small enough to ignore the terms of the order of theta cubed and higher, find approximation to the following sin 2 theta over 2. Now, what we do here is, what it's saying is that we need to ignore terms of theta cubed and higher, and that gives it like kind of you need to look out if you have theta cubed just to ignore it. So this is an example of this. So sine 2 theta, we can convert that using the double angle formula. You might have done that. If not, I'll probably do a video on it later. But sine 2 theta is just equal to 2 sine theta cos theta. And then we can change that back into a small angle. And then obviously over 2 sine theta cos theta, the 2's cancel here. Leave it just sine theta and cos theta. Then we change it into approximation. These should be squiggly equal signs, but I forgot to put them in, so sorry about that. We get theta because sine theta is theta multiplied by 1 minus theta squared over 2, and then we times the multiply out, so theta times 1 is just theta, theta minus theta cubed is minus theta cubed, and then divided by 2. But obviously in the question we're told to ignore terms of the order theta cubed or higher, and we have theta cubed, so we just ignore the whole of this, and then we're just left with theta, just theta. That's it. So let's look at why when theta is low, why do you have to use these certain approximation rules, I guess. And this is why really. If we have a sine graph, this part of the sine graph right here, the blue lines, and this is a cos graph on the right. When the angles get so low, you can see that is very like literally zero difference at the end of this graph right here. So it's approximately this. It's not exactly this, it's approximately x. So sine x is approximately x when it's really low, as you can see here. And then on cos, it's pretty much the same. But you might be saying like, why isn't it just 1? Well, if it's just 1, it gets dramatically inaccurate. With this one it doesn't. And what basically small angle approximation is to make simple equations, complex equations more simple and it's used like within physics and stuff. But it's used to make things simpler. Yeah, also this kind of makes it a little bit less simpler, but you know, who cares? So if it was just one, it would go across here and be a big difference really early on. You can see the difference. Here we need to make a slight adjustment, and then obviously if x is low, it pretty much is that. It's approximately that, and that's pretty much why. It's basically used just to make things more simple. So yeah, that's pretty much it. It's a very easy topic. If I was you and you need to like understand questions. That's the most hard bit about this. It's not the actual math, it's the actual questions, and you got to understand what they're telling you. So practice using question banks so you can get questions and like information on what type of questions your exam board will ask, and then it should be 3 marks. Should be not 3 marks, but like 3 as in like easy marks, you know. So yeah, it's pretty much easy marks for you, and that's it. Thank you for listening and watching. Have a great day.